Okay, so welcome back everybody to the second part of my two-part monster session on NetConf and Yang. This one is more about running code. So what we're going to do here is to take a sliver of the things that I talked to you about in the first session and put some code and PDUs and stuff around it. We're going to use a couple of tools, or I am going to use a couple of tools. As you can see, I've moved from standing at the pulpit to sitting at the keyboard because I only have, as I mentioned previous, a single slide for this part of the session. The rest will be using these tools. For a NetConf and RESTConf server, we're going to use a product called confd, or Configuration Daemon. It is a, if you want, an on-device configuration management framework that used to be part of my ex-employer, TailF Systems, and it's a very ambitious implementation. Oh, that's better volume-wise. Now I'm right through your skulls. There we go. We will use that as our NetConf and RESTConf server. We will use a small Python script called netconf console to send netconf content and watch it come back from the server. We're going to look a little bit at a Python library for netconf, a netconf client library in Python is what I wanted to say, called NC client. And we're going to use curl to tickle or to use the RESTConf for the REST interface. And again, I want to remind you guys and girls that this is going to be a protocol exercise. So while there's a lot to say about how to actually encapsulate all these protocol motions in libraries, that's probably for the next session or for the next time I'm hopefully invited back here. So don't be tempted to think that the tools that I'm using to show you what's actually coming over the wire are the only tools. You know, I've purposely picked things that does expose all the XML and the JSON that you can think of in these things. And again, there are many higher level tools to be used across these protocols that would make them immediately useful to operations teams. But again, that's not the intent or what I've planned for this session here. This is to teach you exactly what it looks like for NetConf and RESTConf. Okay, so we can get rid of PowerPoint. I'd like to present my shell. This is where we will spend this session. And as much as I understand and have done this a couple of times, I'm going to have to switch back and forth a little bit to a demo script, so hopefully you guys don't get seasick when I do that. That's going to look like something, or say we can take this away as well. That's going to look something like this. All right, so we have a recently started NetConf server running in the background here. That's the confd session that I told you about, or the confd server that I told you about. We're in an aptly named directory called NANOG demo, and inside this we actually have a directory called netconf queries. And we're going to start by using the netconf console program here, right? So newly started netconf server, it's running on my local hosts. So the only thing I need to add to netconf console here is how much I want to see. And since this again is a protocol experience, I'm going to ask the netconf console to show me everything.
So this server is,
yep.
This is the management device, and you have something that is simulating devices being managed as well?
Good question. I would have probably needed another slide for that. So the netconf server that is commonly located on a router or switch in the distributed network is for this purpose running on my laptop. So I'm going to talk to...
The server runs on the router and the client runs on the laptop.
See, that's another thing that I maybe should have put in the framing. In the netconf world, we've opted for the client and server terms as opposed to, for example, manager and agent, which we talked about for SNMP. So the client sits with the management software, and the server, which takes requests from the client, sits in the network elements, right? So in the netconf case, netconf servers would be running in your, Juniper, Cisco, Alcatel-Lucent boxes, and the clients would be located in the EMS or the service orchestration system. Oh, would you prefer manager agent? or something.
I just think, because everybody thinks of the server as the essential and big, and the clients are the small. I mean,
True that. Server is something that comes from, I guess, from Compaq or HP or Dell, right?
yeah, confusing everyone.
So good choice then. You all woke up. That's great. So the NetConf console then, just to be very clear, is our client, and it's going to query and manipulate the data that's residing on the NetConf server, and that NetConf server instance happens to run on my laptop and not on a virtualized or physical network element somewhere else, just to make it more of a lab environment here. Okay, so the first thing that we would do, as I mentioned in the previous slot, is that we would issue what's called a hello, right? So in this case, we're going to use actually a feature of the NetConf console to send the hello message and start the capabilities exchange. So here's what we get back from the server. So I want to walk through this in some detail. So this server tells me that it actually supports both versions of the NetConf base protocol, 1.0 and 1.1. And depending on what the client sent, the session is going to be based on either of those. The only big difference between them has to do with framing or chunking, actually, which we changed between base 1.0 and 1.1. And then there's a number of, let me see if I can make it more readable, capabilities that has to do with the NetConf protocol itself. So in this case, we can see that the way the server is set up, you can actually write configuration data right into the running database. So an edit config towards the running database would make configuration bite immediately, if you like, traditional CLI style. But we also have a candidate, which means that we can opt to edit the candidate to our heart's content, and when we're done there, we can copy that content into the running. So we support both here. And there's actually support for the confirm commit. All these things I will walk through in gruesome detail, but the confirm commit is then the timer-based commit that I mentioned in the previous slot, where I can say, go run with this, but if I'm not back inside of a number of seconds, roll back. And if I kill the session or lose contact while that timer is running, roll back. We support XPath for queries. We support the opportunity to validate the data in the candidate before sending it to the running database. We support also rollback on error. So if you find an error somewhere in the data set that you're sending, the server will actually roll back. We also have some proprietary extensions. So this is a way for the vendor, in this case TailF, to explain to the client that we actually have a new ability here. And in this case, it's something called actions. So it's not RPCs the way standard NetConf is designed. It's actually something called actions, which is kind of an RPC that you can put inside of data trees. So you can have a reload action, for example, associated with a line card. And then there's a number of Yang modules supported. Down here, you'll see a number of proprietary modules. So AAA modules, a couple of things that has to do with web UIs and monitoring. It's also a third-party but non-standard module supported. So it's something we pick up from yangcentral.org, which is a kind of a loosely held repository for useful Yang files or Yang modules. And there's also some IANA and ITF managed modules, in this case largely around types, access control management, and some of the monitoring capabilities that we have standardized, NetConf notifications, and general types. So this is the complete way for the server to tell the client how you can interact with it using the NetConf protocol, which extensions, which optional extensions to the protocol it supports, and which Yang modules, be that again proprietary, third-party, or standard, that can be manipulated here. So this should give the client developer a complete understanding of the entire data set, the structure, syntax, and semantics of the data that you can manipulate in this box. You're not supposed to have to query for other things, again, like version of some sort of a vendor name or ID. This should be a complete description of the entire data set. Okay, so the next thing, now that we know what it supports, the first thing we could do for this demo or for this session is to issue a GET request on the root, right, without a filter. This will ask the device to dump everything it knows, both configuration and state data, to the client. This is one of those things that if you really want to stress real implementations of NetConf, let's say big core routers and things like that, this is usually a very mean thing to do, because it usually takes a long while for a router, a real implementation, to collect both all operational and configurational data in a timely manner and ship it to a client. So it's something that you can use if you want to try and break things. Now we have a pretty limited implementation here, so this is pretty snappy. So here you'll see in this RPC reply a set of data. And here you'll also start to see, as I mentioned before, identifiers for YANG modules using namespaces. So when the client sees this, it knows which YANG module this data is valid according to. Okay, so here's kind of the back pointer from the content into the YANG modules that the client should know about at this point. Right, so here's where namespaces becomes useful. So if we keep looking for them, we will see that, so we had AAA, here's the conf monitoring, and here's the actual content of the module that we're going to play around with, which is then from a third-party environment, the YANG Central repository. Here's our access controls. You'll see a row-based access control according to the standard model from the ITF. And here's netconf state. So here's actually another way of getting to the same data that we got in our hello, but inside of the protocol session. So if you have for some reason you want to see these things again, but you don't want to tear down the netconf session, you can query for this namespace. There's also types, right? So inside of this data model, we're leveraging or reusing a data type from an external or from a separate module, right? So if we look at it in this YANG file, you'll see that they have borrowed the transaction ID type from netconf monitoring, and they're using it here, right? So for completeness, of course, we need to point out the namespace here as well. Okay, so that's the entire thing. The second, of course, basic primitive feature we have here is get config. So remember, this will fetch only configuration data, right? So it will leave the state data out and just get the configuration. So that would be somewhat different. AAA is still configurable. We have configuration stuff in DHCP and ACM, but we don't have the monitoring things, for example. So the data that I mentioned you could fetch that would describe the capabilities is obviously something you wouldn't configure. So that's operational data, hence it doesn't arrive when I do a get config like this. Okay? And let's quickly look at the same thing, but using RESTconf. Okay, so RESTconf then uses HTTP and the well-known HTTP verbs to take and format data according to a YANG model and send it to the client, right? And we have two encodings. We have XML and we have JSON. And in this case, where we don't send any accept headers, it's going to arrive, ooh, oh, that's interesting. Oh, my first snag. See what that is. Oh, here we go. Okay, let's do that again. Why would you do that? Here we go. So this is querying the top level of the REST API, right? So this would be the URL for the top level, and of course, just as with any other REST interface, you will have to know where to look for this, right? There are trickeries around using particularly crafted URLs and using the well-known namespace, but you will have to find the endpoint for the REST interface before you can start querying it. And for this implementation, this is where we're at.
Sorry, RESTconf is an alternative to NetConf?
It is an alternative protocol to use REST-like primitives or REST-like technologies to manipulate data that is modeled by YANG. So it's got the same consistent data store in the bottom. It's just another way of getting to the data and manipulating the data.
What do you see as the pros and cons of the two protocols?
Thank you for asking. That's a good question. So in general, you know, netconf is a context-specific protocol, right? It's got a lot of features into it as primary features that has to do with the distributed domain. Things like the underpinnings of transactions. RESTconf is leveraging REST, right? REST, for example, has the idea that there should be no side effects. Hence, you can't do transactions, right? So for lightweight, one client to one server, fetching and simple configuration changes, RESTconf is great. For distributed domains where you need transactions, netconf is probably your best bet. So we also see things like RESTconf on top of controllers, where there's practically no distribution, right? It's just a single server. While there might be a use then for netconf in the actual distributed network elements themselves. Does that make sense? Kind of. Okay, I'm going to show you then, of course, what it looks like over JSON. What is this? This is mean. Hang on. That's not it. So here's the JSON. It is not very beautiful. We'll look at bigger models, but of course it's the exact same thing. We just asked it for a different encoding over the wire, right? So now it comes down to programmer preference. Would you rather whip out your XML library and parse the incoming content, or would you rather use your whatever native way you have of parsing and ingesting JSON? But it's the same data, and it's driven by the same data model. So we can actually look at the running database, of course, in the same way. What we saw with the first queries was just the top level content. So here's the actual running database, and you would be not so surprised to see that it is the same content as we would have over netconf. It's just that this is the running database, which by definition is the configuration only. And of course, you can ask for it over JSON instead. So you will see this is the same data, but it's JSON encoded. Okay. Okay, so if we look at this, the way we fetched the schema again, or looked at the output of the hello message, right? So a couple of modules here. And the one that we care mostly about today is the DHCP module, okay? And we know that its identifier, it's DHCP. So now we can do a get schema equals DHCP. So this tells the server to send us the actual content of that schema. So again, if you open up a hello, if you have a capabilities exchange and the hello message from the server tells you that there are now modules that you have never seen before or new versions. This is literally how you would go about updating your disk-based library of Yang modules or whatever you need to do with it to be up to date, right? Another.
Do you expect that the server, the router, or whatever, would actually have this in textual, or would it have to go off and struct this somehow from its underlying implementation?
I would strongly suggest they would have it textual. Strongly suggest.
Why?
Speed. And because there's no reason, I mean, remember, it's the schema, it's not the content, right? So there should be little need for assembling things. It should literally be a part of shipping code should be putting the Yang file on the file system and just serve it.
Right, but presumably you wouldn't fetch this if you don't know what this is, okay? So you would assume your network manager would know this already, ship it to manage the file. And presumably the router itself, the actual implementation of this is written out in C or whatever.
Yeah.
So this is just sort of an informational piece like that.
It is an informational piece, but it's a pretty crucial one, right? Because it means that any interested client can acquire, you know, the kind of contract between the network device itself and the client world, right? It is almost like a promise from the device. That these are my current data sets that I support. And you can always go to the source for that. There's never a, we kind of close the gap for slippage, for example, in release versions, right? Because you can always, you know, if you're a vendor, you can literally always tell the customer, just query the router. You can always, you can go to the horse's mouth, if you like, and get it from where it matters, which is the actual implementation.
So that's different from the common between the SMPs where you might ship the software version and the bits as a separate file.
Which I'm sure you know has led to eons of painful mistakes. There were never a way in SNMP to actually query the box for its MIBs, which was, in my mind, you know, something we should have done for SNMP as well. And you would be stuck with offline libraries where there was no structured version numbering either, so you could never be sure that the MIB file I have on disk is actually what this agent implements, because there were never, you know, version strings. So this is trying to really solve or dissolve that problem. Okay, so let's look at this. Let's actually look at this. Let's look at it in a more calm. No, let's look at it here. So you get the headers, of course. We have a particular namespace. You've seen that before in the capabilities exchange. We have a prefix. So if people import this, you know, this is how they would namespace identify this. We use the Yang types module, which then obviously also needs to be present in the capabilities exchange. We use the IETF INET types, and we use a couple of tailf specific common data types. So first of all, we have a grouping. And we talked about groupings in the previous lot, right? This grouping is called subnet list. So we have a list of subnets that we can reuse by name, okay? This list has a key called net. This key leaf is of type INET IP prefix. So it's a well-known data type. And since it says IP prefix and not IPv4 or IPv6, it's actually a union of IPv4 or IPv6 prefix. It's got a container called range with presence. So if this container actually exists, if an instance of data of this container exists, this box has enabled dynamic address assignment, right? In this container, there's a leaf called dynamic boot P, and it's also empty, so it has kind of presence meaning. If this is present but empty, it allows boot P clients to work on this range, and you have a low and a high address. And they are both mandatory, which means that configuration that lack either of these is not valid. So you can't create this container without providing values for low and high. We don't have default values here. We could have default values, and that would remove the need for mandatory, because if you create it and don't have any input data, the implementation would just take the default value, okay? We have a container DHCP options. We have a leaf list of routers. So of course you can have a number of routers in this container, right? It's ordered by user, so there's some semantics to the order. It's up to the client to order the entries of this list, and usually in priority order them. You got a domain name, and we reuse the INET domain name here. You have a max lease time that defaults to 7200. It's in unit seconds, which means that if you create max lease time but don't submit a value, it's going to pick 7200. And then we come to kind of the meat here, the DHCP container. So you have a max lease time for DHCP, defaults to the same thing. You have a default lease time, and here's where it starts to get interesting. Here's a must statement that says that the default lease time cannot be longer than the max lease time, right? So we can capture those that mistake before hitting the actual instrumentation by just looking at the data incoming, right? And the default for that is 600. And here's how we instantiate the grouping that we started out with. So here's a subnet list. Here's where that is actually, let's say, expanded into the data tree. We got a container shared networks, which is a list of shared networks with a key name. It's got names, and it also uses the subnet list. It's keyed off of name, but it's a set of subnets. And we have a container status, which is config false. So this is not configuration data, right? It's actually state data. So it's the content of this will not come to not be returned if we do a get config, right? So it's typically, the way I usually think about it, it's typically something that you wouldn't expect in a backup file. So those are the leases that we have. Yep. That's right. Config false on a container declares everything under that container to be config false. Because, and this is where it starts to get, you know, even my head still spins. If you try to put a configurational parameter inside the scope of something that is operational, what happens if that operational, you know, state goes away? And again, what happens if you take a backup, right, of something that relies on configurational state? That configuration state changes and you try to roll back, right? So you're absolutely right. That config false on a container says that below here we can't have any configuration. And I mentioned RPCs, and in this case we're using the tailf extension called set clock. So we have some input, so clock settings, so we can set time, and we won't allow this call to, we don't allow the call to arrive with clock settings empty or without clock settings. It makes no sense to try to set clock without clock settings. It's not mandatory though to express if this is UTC or no, and whether we're going to try and sync with the hardware clock. And the output will be a combination of the system clock and the hardware clock. So, and they're both leveraging the Yang data type, date and time. Okay? We can also use the Pyang tool. My producer wants to say something. I can. I will repeat the questions. Thank you, sir. So there's a tool called Pyang. So if you want to take a quick look at the structure of any module, I would strongly suggest you look at Pyang and its output format called tree. So I just so happen to have up here the DHCP Yang module. I hope I can resolve all dependencies, otherwise we'll have to go work on that. So here's the same data that I just showed you, but in ASCII tree format, okay? And it's got a particular way of coding things, but this is easier to get an overview of than scrolling through the Yang file itself that I just did. There are also many other output modules for this, including, for the so inclined, a UML output module that can take Yang and output something that looks a whole lot like UML. So it depends on your needs. Okay. Now we're going to start in on the actual network. Yep. That's right, it's a parser validator. So the question was, Pyang is a tool. Yeah, so as an input, it takes Yang files, it parses, validates, and it's got a fairly flexible output format plugin environment. So in this case, we used a particular output format called F3, or tree. And there are many others. And it's open source, and it's available at I think it lives at Google Code. All right. Now we're going to get back to netconf console, but we're going to actually start looking at things here. Let's do this. No, let's not do that. Let's do this. We're going to look at a simple XML request for a filtered GET request, okay? So what you'll see here is a complete session. So of course, every time we start this up, we're going to send a hello, get the capabilities back, do our RPC, and then close the session. But the important content is in the middle here. So here you see the layers again, right? Here's the RPC layer. Here's the operation. In this case, we actually have an additional layer of semantics, which is a filter. So we're going to filter on this namespace, which is the DHCP namespace. And we're going to filter on DHCP, so only show the subtree below DHCP. So we would do netconf console. And what comes back, not surprisingly, is something that has inside the data enclosure only the namespace for DHCP, right? It leaves the rest out. response from the server.
So for the original one, the edited was the command to the server.
Right.
Which was a net count and not count.
That's right. That's right. Yeah. So what I just showed you here in the editor session, this is the actual netconf payload that we're sending. So I'm asking the client to send this in rapid succession and see what comes back from the server. So, so like you said, I'm sending a netconf RPCs and I'm showing on the screen the output that comes back. Again, this is on the protocol level, which is very specific to this session here today. This is not how you would do it in your day-to-day operations, but to show you the way the protocol works. Right, so that was a get, right? So it would get all the things under DHCP, also the status, right? So down here, and we happen to know, because we've looked at the YANG file, that this is not configuration data. This is actually the leases that we have outstanding. So if I would use another call called DHCP config, which uses another RPC, and the big difference here is that we're using the get config operation. And if we use get config, we actually have to tell the server which database we want to peek at, right? So in this case, we want to look at the running database. We're going to use the same filter, and we'll see what comes back. And what you'll notice here is that there's no status subnet, right? There's no status subtree. So we're only fetching the configuration. So again, this content is what you're supposed to be able to put to the side. Your router, or in this case, the DHCP server crashes. You take that content and you push it back, and you're supposed to be back to exactly where you were. So this is the semantic difference between operational data and configuration data. Okay, so let's go into the more interesting things. We're going to start updating things here, and we're going to start with just manipulating the running data store. So we're going to write right into what it's doing right now. We'll get to commits and the candidate later. So we'll start by using actually, let's start by, set the default lease time to 1 hour. So let's look at what that looks like. So this has got more moving parts, and again, this is protocol level stuff. So it's an RPC, it's got an edit config, and of course the box wants to know which database do we want to configure. We want to configure the running data store so it bites immediately. And we want to config in the DHCP subtree, okay? So we're going to address this namespace. And what we also need is actually to express which operation, right? So the ways you would manipulate data are, you can do things like add, delete, and merge, right? So in this case, we're going to use the merge operation, which means that we'll take this input data and merge it what it has already. So it doesn't matter if this value exists from before or no, we're just going to put it in there. So we need the namespace from the netconf base protocol. We're going to update it to 3600. And then we're going to close the session. Not much to happen here, right? We just had a successful return. So the server said okay, which means that the value is now updated, right? So nothing particularly exciting there. Now let's do something more exciting. Let's look at the invalid data set. So down here, we're going to put the default lease time to something that we know is higher than the max lease time, right? And this is not allowed according to our YANG module's must statement. So if we do that, we should get a more interesting feedback. Whoops. So here it tells me, and of course this again is based off of the YANG that's loaded into the agent, right? So this should happen far before you upset the actual instrumentation, the actual router running code, right? You get an RPC error with a number of metadata. So it's application level, it's an operation that failed, it's an error. So it's a violation, right? And it's a must violation. And the error path in this case is in the DHCP namespace, and it's actually in this subtree of the data set, right? And the error message in English is exactly what it said in the Yang module. So it literally sends what the Yang model describes as the error message because it broke the constraint. Now we're getting a question on the mic. Great.
Yeah. Yeah, I'm Richard Campbell. I'm with Priceline. Just a quick question. Can you variabilize the output messages so you can actually specify the actual least time max in the error message so you know what that target is?
That's actually a vendor extension, not in the base definition. No variables in the base. But it's a very useful vendor extension, as you can imagine. All right. Oh, one more. Yay.
Ralph Mullen from the Internet Archive. If I want to implement one of the newer DHCP features, say DHCP option 53, at which point would I learn that a particular device doesn't have that implemented? Is that something where I can validate it on the client and it already knows because the device told me what it can do? Or is it something that I would only find out when I try to load it into the server on a particular router that is not supported?
In a well-behaved and ambitious implementation, you should be able to infer that from the Yang modules that you can fetch from the box. It should be able to tell you its entire available data set, both configuration and operations. So that should tell you what is possible. Then if you remember from the most recent, from the previous slot, right, it's the feature, we have the feature construct that you can use for runtime things. So maybe it has a feature that's called option 43 or whichever option, right? And you have to check for whether that's actually turned on. And if it's turned on, then it's available. But normally, and I'd say it's more prudent to have that in the actual Yang itself to describe what the box can do. Thank you. Okay. So what we can look at now is that we can look at removing things. So we just added something, and then we failed an add as well. Let's look at deleting things. So what we're going to do in this case, we're going to, so again, it's an RPC, it's an edit config, target is running. The big difference here is that we're using the remove operation, right? So in this case, in the DHCP namespace under shared networks, we're going to remove a shared network that has a key with the following name. Okay, so that's all we need. Since this is an entry in the list, all we need is an index for that entry and use the remove operation. And that should remove everything below it in the list. Not much happening here as well. So this is an OK. So we now have removed the 2249. So of course our data set, sorry, get, there you go. For the DHCP subset is much smaller because we removed the entire subnet, right? And since we're doing this to the running database, that happened immediately, right? So the box said, with its OK, it said, I'm now running under the new configuration right away. Okay, so it's removed. So let's look at how to use candidates. So what we can do here, I'm going to start stealing things from this, is to ask for, the content of the candidate. So this is a recently started netconf server, right? It was cold started half an hour ago, which means that when you check the candidate database, if you're the first visitor to the candidate database, it's going to have the same content as the running. Now, if you can't trust that it actually has the same content that the running because someone has edited it, you do what's called a discard changes. So you make sure that the candidate database is the exact same as the running database. And you probably do that under a lock. So you can make sure that no one sneaks in changes while you're doing these things. But again, that's the ambitious route here. Okay, so we have a copy of the running in the candidate. So we can now actually start removing things from the candidate here. Yeah, I want to show you this first. And So we have another example of an edit config, this time targeting the candidate, that is also using an invalid value of the default lease time, right? So to show you that also the candidate does or must checking, we can send that invalid value to the server. It will say the same thing, it's just that now we're trying to do it with the candidate, right? So some things you can check also on the candidate, while others are checked on commit from the candidate to the running. There's a single global candidate. I'd say it's kind of on the top 3 frequently asked questions, and the really tricky part here is leaf references, right? Because if you started, in the general case, I mean, you can have leaf references pointing all over the data set, right? And it'd be very tricky to implement editing on subsets that you could prove didn't impact other sessions, right? And I'm sure as we get more experienced with this, more implementations, more best practices, we will come up with a way that would allow several writers at the same time, because it just screams for it, right? But it's really hard to even, imagine what that would look like that would also kind of satisfy or fulfill the features of Yang, right? And yeah, that is just a very tricky proposition. So locking and single candidates is what we have right now. And of course, the point being that if you have Yang and if you have netconf, your editing sessions should be sub-second, right? It should literally be a very fast thing. Also, I mean, if you think about transactions, this is all going to be in the critical section. So it behooves the client developer to really keep it snappy and fast and not lock something and spend time in there.
Okay, so then create your candidate session, write it to your running config. You want to say, let's do this for a few seconds there. You just text that you've done this so that you know that they're in the middle of making changes that might get rolled back in whatever time because it hasn't succeeded.
That's where locking comes in. So unless you lock, that can happen. But if you make sure that you discard changes and then lock, you avoid that. Because anyone that tries to sneak in changes while you're waiting for a confirmed commit will be held back by the lock.
Okay, so you execute your current commit, but it's still not, you don't know, how do you know when that time interval expires?
So you see that in your session. And if you close the session, it's going to roll back. So you have to wait in the session. It's a session protocol. Yeah.
How do you know that somebody else isn't? All right, you can have it.
Oh, thank you. And just what they asked for as well. You have such a booming voice. I just assumed that it reached to the other end of the...
Sorry. So my question was, how do you know that somebody else hasn't done a confirm, has set a commit, is waiting for the time to expire? How do you know it's safe for you with a separate client to go in and make changes to it?
So you mean if there's an outstanding confirmed commit and you try to start one, so the implementation won't allow you to do a confirmed commit if there is one already running. So there's by necessity serialized, right? You can't have 2 outstanding confirmed commits at the same time. Thank you. So we're going to add back the shared net, but we're going to add this back in the candidate, okay? So the shared net that we just removed, we just added that, but we added it not in the running, but in the candidate data store. Let's take a quick look. And you guys know this by now, but here's the big difference. So it's an RPC, edit config, it's to candidate, and it's the subset of the data that we just removed. So if you remember, we removed a shared network with this as key, and now we're putting it back. I just happen to remember what it said here. But now, again, it's still in the candidate, right? So we haven't committed it to running yet, so the box isn't running on the assumption that it should have those subnets yet. So what you can do here, which can be very powerful, is to send a validate, issue a validate request, right? And in this case, again, it's an RPC. It's a primary RPC called validate, or a feature RPC called validate, part of the netconf base protocol. And it validates the candidate. It just says, look at the content here and compare both with your Yang declaration, and if you have other things you want to check as well, do that. So this is also part of the kind of two-phase commit, because this is the prepare phase. So you can ask the device to say, to tell you that it's reasonably sure that this is valid, right? So this is the prepare step in common database lingo. And of course, we hope that this is all well in this case. So it will return, oops, it would return okay. Okay, so it's validated. So now I have a high degree of well, I feel confident that I can commit these things. So let's look at that. Pretty straightforward, right? Commit doesn't actually target any particular databases. It's inferred that it's taking the content of the candidate and putting it into running. So all you do is issue a commit like this. And it worked. So now we have put back, whoop, the shared network 224-29 into running. Okay, so we put it back. Okay. So let's do this. I'm going to do this a little bit quicker. We're just going to remove the shared net from the running again, because I'm going to show you a confirming commit. So, which means that we remove it and we add it to candidate. We've seen that before. And let's look at this set here. It's an RPC. It's a commit. It's got the confirmed flag set, and the confirmed timeout is 10 seconds. And the persist ID, if I wanted to do something about this later, is befittingly enough NANOG. So in this case, I'm going to let this actually run. Let's do this. So we commit it, and let's see if we can get the ECP config. You see 224.29 here, and we'll wait 10 seconds. You can peek at the log. It's gone, okay? So the device timeout expired, and the implementation itself rolled back, right? So this is useful when you, because most of you guys probably have done this, configure yourself away from management reachability. Because then you lose the session, the timeout will expire, and the device will roll back itself. So if I redo this with a add shared net, let me just look at it. Do a commit confirmed, and then we do a confirming commit. It's going to bite. So the timer is now taken out of play here, and the configuration will stick. Any questions? Okay. Oh, good. So the persist is if you have an outstanding confirming commit and you want to manipulate it later, it's the ID to, for example, cancel the commit. Right? You need to be able to identify that you know which one you want to cancel, even though there can only be one outstanding. Okay, good. So getting closer to wrap up here. We're going to talk a little bit about, no, actually, I think we need to actually stop here. Any questions, guys and girls? A lot of XML, a lot of PDUs flying back and forth. All crystal clear? There's one.
So if we wanted to replicate what you did here today, What's the easiest way to sort of build this setup? Is it all stuff that you gotta go build from source and then you can run these tools, or are they available in the standard repositories for Linux distributions, or what?
So there's two sides of this, right? There's the client tools, as I mentioned in the PowerPoint, right? And the ones that I use are all actually available for anyone. So the netconf console, you can find that. The NC client and curl obviously are readily available, right? Now the conf D, in this case, the server is not, right? Right now it's still a proprietary solution. We are working to change that. So I now work for one of the vendors, and we're trying to make this actually something that will be freely available, but it isn't right now. There are other open source implementations of netconf servers. There's one called Yuma, there's one called libnetconf, and there's one called freenetconf. And they're all fine, and you can use them, of course, for these types of exercises to your heart's content. And you can always use one of the major vendors' boxes. I'm not going to point one out, but you can also ask them when if they don't have it, to your surprise, you can always ask them when they're implementing it.
Just one more question. Do you know of operating system vendors looking to use this, like Apple or Microsoft or Linux, to be included as a default, so you can actually manipulate host configs remotely?
Say that question one more time. Sorry, I didn't catch the beginning of it actually.
Do you see like OS vendors implementing netconf in their OS? So it's not only can you configure and manage routers, but you can configure and manage end clients or hosts.
Okay, so for that type of environment, there's an abundance of other means of configuring, right? And I'm not entirely convinced that netconf is a appropriate protocol for, let's say, server-based or application-based configuration. Now there's a big gray area though, with applications like DNS and DHCP and things like that. DHCP, of course, being today's example, which is inherently network-centric, that inherently has a configuration data set that you might want to manipulate, where there are actually some vendors that do implement these things for it. And of course, one of the many things that we're pushing for is for the appropriate applications, things that would be facing, let's say, a network service orchestration environment. Netconf and Yang is fitting, right? So we are trying to push for standard models for it. We're trying to push for open source implementations of it. And we're trying to push for vendors in that space to implement it as well. Because again, having the basis of transactions and allowing them to participate in that, spanning the network assets, can be a very powerful construct. Yes, sir.
Just to follow on the previous question, if we wanted to reproduce this ourselves, is there some instruction somewhere about how we could do this, or would you be able to post somewhere some instructions from just, obviously not the conf D part, I guess, but all the other parts?
It's a very fair ask. Actually, I'm going to take on myself to put something together and make sure that the appropriate people at NANOG can distribute that.
Thank you.
Here.
Hooray, more questions.
I have questions. Oh. Go on.
Brian Knight from Nitel. I have a general question. You've been showing us a lot about how the XML transaction itself and what it does. How would we use this in our daily lives? What would be the workflow? Would we write our configurations in Yang and use some tool to transmute them into XML and send it to the server, or would we write it in XML? How would that work?
Yeah, so I mean, there's two sides of it. If you're a vendor, if you build network elements, you would hopefully kind of adjust your tooling to start using Yang as the way to drive your manageability framework, right? So when you would spin a new release, right, you would actually drive the CLI and the netconf interface and what have you from a set of Yang modules, which would give you the benefit of being able to serve your customers, people that would code for this, a Yang file that accurately reflects what that actual version does, right? Mm-hmm. And for the client side, I mean, there are many ways. It helps you all the way from just basic scripting, even though as painful as that is, and probably doesn't help much over tickle scripting for CLIs, right? all the way to, and this is probably the subject matter of for additional sessions here at NANOG, but what I'm showing here again is just the raw protocol, right? And then there is a variety of language bindings for this with various types of abstractions. So you have Go language bindings, you have Python, of course, Ruby and many others. So that's great. Then you can abstract away the actual, creating of XML and sending of XML. Some of these libraries also have Yang bindings, so they can actually take Yang and produce data model specific APIs, for example. So you can traverse data sets using generated APIs or generated object models, right? And of course, on top of that, there's entire systems that can consume Yang and actually build moving parts out of it. So you could build something that could express, for example, services traversing several instances of netconf and Yang.
Okay. So the goal is not to have Yang be the language to necessarily define configuration and pick, oh, I want this particular DHCP subnet to be used. That is, Yang is more of a data modeling language, and XML is the way to send that to the device.
Exactly. So Yang describes the data set that is available to you to manipulate and read on the device, right? And the XML that you see flying back and forth here is protocol-specific renditions of what you want to do to that data set, right?
Thank you.
Hey, Jun Kim from Georgia Tech. So this netconf and Yang looks really good tool, but it looks very static policy pushing. So, actually network, there's a lot of changes going on. So I just want to know, is there any support, for example, do you have to make a Yang program and there's some event comes in, like intrusion or something, and you have another Yang language, and do you just have to use scripts to react to that, or is there any support that you actually can automate that too? Like you want to actually say oh, if this event comes in, I want to just push this and push another one, and things like that.
So that's a good question. So Yang and netconf and perhaps RESTconf aspires to the moving parts of the kind of read side and the write side. So of course you can write things with it and you can read things with it, and you can also accept or take notifications. But the actual tying the things together on the top is actually out of scope both for netconf and Yang, and we're eagerly awaiting clever ways of doing that, because I think what you're saying makes a whole lot of sense and should be a very exciting endeavor for anyone. Now that we have, again, the formalized declarative way of describing both the configuration, operational, and notification data set. But it's not in scope right now for netconf or Yang. Go build it. Would be cool.
Cool, thank you.
Hi, I'm Brennan with Facebook. Thanks for pimping the Go findings. I wrote that, so thanks. But I have another question. Do you see Yang being used outside of a client server model, more like a streaming model, being able to describe data being streamed from the box, as an alternative to like an SNMP poll, for example, right? Getting more real-time information. I always want, every second, I want my interface counters. And then have Yang be the way to describe that, I guess.
So the netconf notifications can give you parts of that, right? It is a way of saying, for example, the client can say, first of all, I want to see all the streams that are available, right? And I just want to see these streams. The pacing of it, though, is of course out of scope for the client. So, but that could be made a configurable. Now I hear myself also completely overloading what netconf and Yang is about, but and it's one of those that, yeah, you could do that. I'm not sure it's the appropriate way, but certainly you could do that.
Thanks.
Go language, by the way. Don't stop. Don't stop. Any other questions? Okay, for the brave people that have now been here for 2.5 hours, thank you very much. Thanks for coming.